Bonjour baddies, welcome back to another video. It's problem number 18 of the 2025 AMC8. The circle shown below on the left has a radius of 1 unit. The region between the circle and the inscribed square is shaded. In the circle shown on the right, 1/4 of the region between the circle and the inscribed square is shaded. The shaded regions in the two circles have the same area. What is the radius r in units of the circle on the right? Okay, so basically the way we can go about doing this problem is that we basically know that this circle's area minus this square's area is equivalent to this outside area, the shaded area, which is also equivalent to 1/4 of the same process but with a larger one. So this, the other shaded area. So basically, how are we going to do this problem? Well, first we need to know the smaller circle's area, which is actually rather easy to find since the radius is just 1, so pi r squared. The r in this case is simply just 1, so that's just pi. But the harder part comes when we need to find out what the square's area is. In this case, we can basically swap the square as like a rhombus kind of formula, because a rhombus and square's properties are extremely similar. It's just that with a rhombus, they just don't have the 90-degree angles, but all four sides are also equal, and squares also qualify as rhombuses. So basically, if we look at this problem, and we look at this silly little square, the way that we can do a rhombus's area is multiplying both diagonals and then dividing by 2. Since in this case, if we extend the diagonal, our diagonal is equivalent to 2, and the same for the other one since it's a square, we basically have 2 multiplied by 2 divided by 2, which is just 2. Therefore, the shaded area for the smaller circle is simply just pi minus 2. Similarly, with our larger circle, this time we only just have r. So we basically have pi r squared minus, and in the same way, this would be 2r. This would also be 2r. So that would be 4r squared divided by 2, getting you simply 2 and nothing on the bottom. And now that we can insert this into a total equation, we basically have pi minus 2 is equivalent to pi r squared minus 2r squared divided by, of course, 4, because it's only 1/4 of the shaded region. Now that we have this, we can basically divide, to isolate r, we're going to divide both sides by r squared. Not both sides. We're going to basically pull out r squared. It's just literally just a habit of the tongue. Because it's basically, you can think of it as it being distributed into the numerator already, and we're just trying to pull it out, basically. So you basically have pi minus 2 is equivalent to r squared pi minus 2 over 4. Which means that if we divide both sides by pi minus 2, this side is then 1, which means that r squared is equivalent to 4, so r is equivalent to positive or negative, because negative 2 multiplied by negative 2 is also 4. However, since this is a side, the radius obviously cannot be a negative number because it just like goes into like, I don't know, the underworld or something, that the line just stretches down instead. But yeah, it can't be a negative number when talking about sides in geometry. Therefore, the only solution is just positive 2, and as you guys can see, there is no negative 2 solution anyways. So the answer is simply B, 2. So yeah, that's the end of this video. Hope you guys enjoyed, and I'll see you all on the next one. Bye-bye!